Here we have two examples where we're going to be applying the additive and multiplicative principles. So in example 4, we have that a license plate consists of 3 letters followed by 4 digits. So we're using the letters A through Z and the digits 0 through 9. And the question is, how many license plates are possible? So one way to approach this problem would to kind of be to draw a picture of the setup. So we know there have to be 3 letters, so I'm going to draw blanks for those and just kind of make a note that those are letters, and then 4 digits, 1, 2, 3, 4. And these are digits. All right, so we call this a slot diagram sometimes, and basically the idea is we're drawing a slot for each choice that we have to make, and then in that slot we're going to fill it in with the number of choices that we have. All right. So we know that for the letters A through Z, that's 26 letters. So for each of these letters, we have 26 choices. So 26, 26, 26. And then each of the digits have to come from 0 through 9. So there's 10 of them since we're counting 0. So 10, 10, 10, 10. All right. So now the question is, which rule should we apply here? The additive principle or the multiplicative principle? So remember, the additive principle is going to come into play if we're only kind of choosing one item from the different categories, but here we have to choose a letter for each of the 3 slots and a digit for each of the 4 digit slots. So we're going to be doing the multiplicative principle, so I'm going to put the dots in there, and again, that's because we have to fill each slot with either a letter or a number. So when we multiply those all together, if you want to use kind of an exponential notation to make it a little bit shorter, we have 26 cubed times 10 to the 4th, which ends up giving 175,760,000 possible license plates. All right, so now in example 5, is asking how many functions there are from this domain set, which is the set 1, 2, 3, 4, 5, to the codomain set, which is the set containing A, B, C, and D. So first we'll just answer the question of how many functions are there. All right. So one way that we could kind of think about this is using our 2-line notation that we used before back in the section 0.4. So the inputs or the domain are the elements 1, 2, 3, and 4. And then for each of those inputs, we need to choose the corresponding output from the codomain. And of course, the codomain here we can see has 4 elements. So basically, we can kind of apply the same idea of the slot diagram that we did above, but here we would have a slot kind of as the output for each of these corresponding inputs. And we know that there are 4 choices, because again, there's 4 elements in our codomain, and we can choose any of those to be the outputs for each of the input values. And again, we are using the multiplicative principle here because we need to choose an output for each of those. So for the answer to how many functions are there, we would have 4 to the 5th, which is equal to 1,024 possible functions. All right. And then the second question asks, or the second part of the question is, how many are injective? So injective or one-to-one means that every element of the codomain is the image of at most one element from the domain. So what that would look like in this case, if we're again maybe thinking of the 2-line notation, would be that there's no repeats down here in the range. Okay, so if it's injective, that means no repeats in the range, because that's what it would mean to have every element of the codomain be the image of at most one element from the domain. But if you think about that, there's exactly 4 elements in our codomain, but we need to choose 5 elements to be the outputs, since there's 5 inputs. And basically, we can't do that because 5 is bigger than 4. Or in other words, I guess the answer would be to how many are injective, it would be none. And the reason for that is because the cardinality, right, or the size of the codomain is less than the cardinality of the domain. So for that reason, we would have to have repeats in the range in order to make it a function.